Good morning, students. You have learnt the definition of continuity and some of the problems we have worked out in the earlier sessions, and in different types of problems. I mean, if a point is given, we just find out whether it is continuous at that point or not. If a point is not given, then we take a general point C or A, and at that point we find out whether the function is continuous or not. That is, we find the value at that point and we find the limit as extends to that point, and whether they are equal, we come to the conclusion that it is continuous, generally we can say. And if it is they are not equal to each other, we say that function is discontinuous. Now, the method is same, but the way the question is asked like this: examine the continuity, they may ask you, or find the points of discontinuity. So, the procedure is same, that is taking a particular point or taking a general point, we get the answer, but while writing the answer, suppose they ask you the question like this: find the points of discontinuity, then while writing the conclusive sentence, you have to write at whichever point it is continuous, you have to mention that one. Suppose it is continuous at each and every point, no, then you have to write that it is a continuous function, like that. Suppose there is a discontinuity, you have to mention that point of discontinuity, like that. Depends upon the way the question is asked, otherwise the procedure is same. Now, we proceed to the next type of problem. Here I am going to discuss the continuity of the function which is defined in a particular way. That is, discuss the continuity of the function f defined by f of x is equal to 2x under the condition x is less than 0. Now, it is equal to 0 if x is 0 less than or equal to x less than or equal to 1, and this is equal to 4x under the condition if x is greater than 1. Now, we have to discuss the continuity of this function and defined in a particular way. Let us see here. See, fx is equal to 2x if x is 0. That means that when x takes the negative values, the function would be whether it is continuous or not. Function is defined like this, we have to consider this one. For all x less than 0, function should be taken as fx equal to 2x. Next, when x is greater than 1, that is, for all the values of x strictly greater than 1, function is defined like fx equal to 4x. We have to consider that one. Now, in this particular function which is defined in this way, there are 2 points which come in between in the domain. One is 0 and 1. So, here we have to discuss 4 cases. Find out the continuity for all x less than 0. Find out the continuity for all x greater than 1. At x equal to 0, at x equal to 1. So, these are the 4 cases we have to discuss here. First, let me take the case 1. Suppose x is less than 0. Right here, case 1, let x be less than 0. Then how is the function defined here? The function is defined like this: fx is equal to 2x. Here, for all x less than 0, I am not taking any particular value, any negative value, the function is defined like this: fx equal to 2x. Now, here in general we are discussing means, let me take a point, let c less than 0 be any real number, then we find the value, that is f of c. We find f of c, this would be equal to 2c here, and then we find the limit of the function, that is limit of fx as x tends to c, So, that would be equal to, in the same function, wherever x is there, I write the value c, it would become 2c. Therefore, you observe here, the value is also equal to 2c, the limit is also equal to 2c. Therefore, what is our conclusion? The function is, you have to write that in sentence, the function is continuous for all x less than 0. That is, for the negative values, the function would be continuous. Now, let me move on to the other extreme. I am considering the extreme cases, that is, the case 2. Let me take the case 2 here. Here let us take the other one. Let x be greater than 1. That is, let x be greater than 1. When x is greater than 1 here, how is the function defined? Fx equal to 4x. That is, f of x is equal to 4x. When f of x is equal to 4x here, you as usual, here again I am not giving any particular value, I am just taking a value which is strictly greater than 1. Strictly greater than 1. So what I do is, let c greater than 1 be any real number. Here you make sure that you write the sentences properly. Let c greater than 1 be any real number. Then what is the value here? F of c is equal to 4c. Wherever x is there, replace it by c. So this is the value of the function. And how do you find the limit here? The limit of fx as x tends to c is limit of 4x as x tends to c, that would be equal to 4c. So we got the value to be equal to 4c, we got the limit to be equal to 4c. So what is our conclusion? Our conclusion is the function is continuous for all x greater than 1. So when x was less than 0, the function was continuous. When x was greater than 1, we have seen that the function is continuous. Now at two particular points, 0 as well as 1, we have to find out. So let me come to the third case here. Case 3. Case 3 here, first let me consider like this. Let x is equal to 0. I am taking a particular point. Let x be equal to 0. When x is equal to 0 means here, see here it is strict inequality. Here it is strict inequality. Only in the middle part here we are having the equality. So x is equal to 0 means function should be taken as 0. At x is equal to 0, f of x is equal to 0, that is f of 0 is equal to 0. F of 0 is equal to 0. Now here, while working out the problems, I told you, when a particular value is given, if the function is defined in two different ways, we have to calculate the left hand limit as well as the right hand limit, because this number 0 can be approached through the values less than 0, through the values greater than 0. Now here the value is calculated. So we have to find out the limit here. The left hand limit is limit of fx as x tends to 0 minus, because we are calculating the left hand limit, 0 minus. So when x is approached through the values less than 0, the function is taken like this, that is limit of 2x as x tends to 0 minus. So give the value x equal to 0, 2 into 0, that would be equal to 0. That is, the value of the function is 0. The left hand limit is also 0. To come to the conclusion, we have to look at the right hand limit also. So right hand limit is limit of fx as x tends to 0 plus. For that, now which has to be taken here? See, less than 0, we have taken this as the left hand limit. This is for x 0 less than or equal to x means x is greater than or equal to 0. So the function should be taken as this one, that is limit of 0 as x tends to 0 plus, that is again equal to 0. What do you observe here? The value of the function is 0. The left hand limit is 0. The right hand limit is also 0. That is LHL equal to RHL, that is equal to f of 0. Since all of them are equal to one another, that is the limit is 0 and the value is also 0, we can come to the conclusion that the function is continuous at x is equal to 0. So before 0, after 1 and x equal to 0, the function is continuous. So what is the last case now? The last case is at x is equal to 1, case 4, at x is equal to 1. Now x is equal to 1, again equality. This is the one which is having equality on both the sides here. So when x takes the exact value 1, how is the function defined? That's equal to 0. Write that one. At x is equal to 1, the function f of x equal to 0. That is f of 1 is equal to 0. Here we are verifying at x equal to 1 here. Therefore, f of x equal to 0 means f of 1 equal to 0. Again, this number 1 can be approached in two different ways. Through the values less than x, that is this one. Through the values greater than 1, that is this one. So, for the left hand limit, this should be taken, and for the right hand limit, this should be taken into consideration. Therefore, left hand limit equal to limit of fx as x tends to 1 minus, because at 1 we are calculating 1 minus, that would be equal to limit at x equal for left hand limit the value is 0, that is x tending to 1 minus that is equal to 0. The constant means we cannot give 0 as 1, no, 0 means it is 0 only. So, that is also 0, this is also 0, we cannot say, we cannot come to any conclusion. Therefore, we have to calculate the right hand limit. Now, limit of fx as x tends to 1 plus here, that is for the right hand limit for all x greater than 1, it is approached, 1 is approached to the values more than 1. So, the function is 4x, that is limit of 4x as x tends to 1 plus. Which value has to be given? 1 has to be given. 4 into 1, that is equal to 4. That means you observe here the value is 0. The left hand limit is 0. So, we could not say anything about the continuity. Now, we have seen that the right hand limit is 4. That means that limit does not exist. Left hand limit is not equal to right hand limit, or you can write the limit of fx as x tends to 1. Don't write plus or minus here. X tends to 1 does not exist. Does not exist. That is, when the limit itself is not there, though function is defined at that point, we can say that it is discontinuous, or we can say it is not continuous. So, when the question was like this, discuss the continuity of the function. So, the function is defined in a particular way where we get 2 points inside the domain there. So, less than x less than 0, x less than 0, it was continuous, x greater than 1, it was continuous, at x equal to 0 was also it was continuous, at x is equal to 1, at that point we have the discontinuity. So, how do you write this one? Because the question was asked like discuss the continuity of the function, you can write like this, at x equal to 1 the function is discontinuous. Okay, all the three after each case you write the conclusion. Now you can write it as the function is discontinuous at x is equal to 1. Now we move on to another problem. In the next problem also, we will be having 2 points. So, that means that when 1 point is there, generally there will be 3 cases, before that value, after that value, at that value. When there are 2 points involved in that one, then we will be having 4 cases. See, now the function is like this. We have to calculate we have to verify, or we have to examine the continuity, or we have to discuss the continuity. The function is like this. F of x is equal to minus 2 if x is less than or equal to minus 1. This is the first part. The second one is this is equal to 2x if minus 1 less than x less than or equal to plus 1. Lastly, it is equal to 2 if x is x greater than 1. X greater than 1. So, just like the previous problem, the numbers are different. There we had 0 and 1, but the function is defined in different ways. Look here, when x takes the value either less than minus 1 or equal to minus 1, the function f of x is equal to minus 2, which is a constant, automatically it would be continuous. But we have to argue that. Next, when x is greater than 1, then f of x is equal to 2, which is again a constant, automatically it would be a continuous function. But we take a general point as usual and argue. Now, 2 points are involved again. One is minus 1, the other is plus 1. So, the third and fourth cases, no, we take a particular point x is equal to minus 1 and x is equal to plus 1. So, when you take that one, we have to discuss for minus 1, this is the left hand limit and this is the right hand limit. For plus 1, this is the left hand limit and this is the right hand limit. So, we have to discuss both the cases. First, I will take case 1. Case 1, let x be strictly less than minus 1. I am not considering the equality here. I am taking a value of x which is strictly less than minus 1. Now, what is the value here? In that case, now the exact value of the function is given, that is f of x equal to minus 2. Here itself you can argue and say, since it is a constant function, it would be continuous, or as usual we argue like this, let c less than minus 1 be a real number, be any real number. We just say be any real number. Then what is f of c equal to? That is minus 2, because being a constant, no, it would be same, no change in that one. And when you get the limit of the function also, limit of fx as x tends to c would be limit of minus 2, that can be minus 2 only. So, the value is minus 2, the limit is minus 2. So, what is the conclusion? The function is continuous for all x strictly less than minus 1. That is, when x takes the value less than minus 1, it is negative only. Now, this being minus 2, a constant, the function becomes a continuous function. Now, take the next case. That is, we always better take the extreme cases, then we come to the in between points. Now, second case, let x be strictly greater than 1. Now, what is this one? The function is defined as f of x is equal to 2. Just now I told you we had minus 2, here plus 2. That is also a constant, this is also a constant. So, arguing along the same lines, that is, let the c greater than 1 be any real number, then f of c is 2. Limit is also 2. Therefore, function is continuous for all x greater than 2 here, greater than 1. That is, see, we will be proving some bookworks in the coming sessions, that is, a constant function is continuous, a polynomial function is continuous. We will come to that later. So, after learning that one directly, you can use that reason and write the continuity of the function directly. Now, let us take the case 3, third case. Here, I am taking this point at x is equal to minus 1, exact point I am considering. At x is equal to minus 1, look here. We are having equality. How is the function defined? F of x equal to minus 2. F of x is equal to minus 2. That means when you give the value minus 1, f of minus 1 is minus 2. That is, this is the value of the function. Now, let me consider the left hand limit as well as the right hand limit. Left hand limit, because this number minus 1 can be approached through the values less than 1 and less than minus 1 and through the values greater than minus 1, because it is defined in two different ways. For x less than minus 1, it is minus 2. For x greater than minus 1, it is 2x here. Therefore, we have to calculate them separately. That is, limit of fx as x tends to minus 1 minus. So, the number we are giving is minus 1. How is the function defined? It is limit of minus 2 as x tends to minus 1 minus means it is minus 2. When there is a variable x here, we write the value minus 1. When it is a constant, it has to be written as it is. So, the value left hand limit is minus 2. Let me consider the right hand limit. Right hand limit means which you have to take? Minus 1 less than x means x is greater than minus 1. So, this x is approached through the values greater than, from the right hand side. We can say from the right hand side. That means that the function is, you have to write like this, minus 1 plus. How is the function defined? It is limit 2x as x tends to minus 1 plus. Now, what can be the value? Wherever x is there, write the value minus 1. So, 2 into minus 1, that is minus 2. What you observe here? The value of the function is minus 2. The left hand limit is minus 2. The right hand limit is minus 2. That is, you write the limit of fx as x tends to minus 1. Don't write plus or minus, is minus 2. That is also equal to the value of the function. Therefore, at x is equal to minus 1, the function is continuous. So, less than minus 1, it was continuous. Greater than plus 1, it was continuous. At x equal to minus 1, it is continuous. Now, we discuss the fourth case. That is fourth case. What's the remaining point? At x is equal to 1. Exactly. Look here. X is equal to 1. Equality is here. Therefore, first we find the value. That is f of x equal to 2x. But we are getting the value at exactly 1. That is f of 1. F of 1 is 2 into 1, that is equal to 2. So, this is the value of the function. Again, as usual, this number 1 can be approached through the values less than 1, through the values greater than 1. Through the values less than 1 means this is how the function is defined. Through the values greater than 1 means this is how the function is defined. So, we have to calculate both of them separately. Left hand limit is limit of fx as x tends to 1 minus, that is limit of 2x as x tends to 1 minus 2 into 1, that would be equal to 2. So, we have the left hand limit equal to 2. Come to the right hand limit. See, this was also 2, that is also 2. So, we have to get the right hand limit. Limit fx as x tends to 1 plus. How is it defined? It is 2, the constant itself. So, we are having a constant here, means that itself becomes the value. That it itself becomes a limit here, whether it is right hand limit or left hand limit. When there is a variable, we write the value and calculate. When it itself is a constant, then automatically that becomes the limit. So, the value is 2, the left hand limit 2, the right hand limit is 2. So, at x is equal to 1, the last case we are discussing, that point also the function is continuous. So, how do you write the conclusion here? At x less than minus 1, the function was continuous. At x for all x greater than 1, the function was continuous. And at x equal to minus 1, the function was continuous. At x is equal to plus 1 also, the function was continuous. So, what is our conclusion? At all the 4 cases, since the function we saw that it was continuous, generally we can write it is a continuous function. The conclusive sentence after considering, sometimes if in the previous problem there was discontinuity at one point. In all the remaining cases it was continuous. So, how do you write the answer? At x equal to a particular point it was discontinuous. In this case, since for all the values it is continuous, we can directly write that one, that is the function is it is a continuous function. Since we are taking all the 4 possible cases, we can come to the conclusion that, and in all the cases we have seen that it was continuous, we can directly write it is a continuous function. Or if the question is asked like this, find the point of discontinuity, then how do you write that one? There is no point of discontinuity, always depending upon the way the question is asked. Discuss the continuity, then you write the conclusion, continuous or not continuous. If the question is asked, find the points of discontinuity, you have to write that at a particular point whether it is discontinuous. Or if there is no discontinuity at all, you have to write there is no discontinuity at all, there is no point of discontinuity. Or you can write it is a continuous function. Both are correct. Now, one more problem I want to discuss now. This is again a little bit a different problem here, because in the way the function is defined, we do not have any variable in the definition of the function. I will show you that one. When I write, you will know the meaning of that one. See, usually you might have observed that when we write the function fx, it may be 2x or 3x or x square, whatever it is. Sometimes we have written constant also. Here f of x is equal to 3, 4, 5. That means that in whatever way the function is defined, it is simply a constant. And here some conditions are there. If 0 less than or equal to x less than or equal to 1, first case. Second case, if 1 less than x less than 3, we have strict inequality. And the last one, the condition is 3 less than or equal to x less than or equal to 10. Could you observe any change in the definition of this particular function? See, each and every problem is little bit different from the previous one. That means while defining the function, what I am telling, there is a slight change in the definition of the function. Here most of the problems we had, we did not have this one, x less than or equal to 1 or minus 1, strictly less than 1 something. And here also x greater than or equal to 3 or greater than or equal to greater than 1, greater than 0, something was given. Here you observe for all x less between 0 and 1. So it cannot go beyond below 0 here. So 0 starting with 0, the function is defined here, and here ending with 10 here. Beyond 10, no, we are not considering, and before 10, before 0 also we are not considering here. So here we have a restricted domain, we can say. In all the earlier problems, this portion was not there and this portion was not there. That is, x less than some number was given or less than or equal to. Here x greater than or equal to or greater than some number was given. This part was not present in the earlier problem. So this function is defined in the closed interval, that is between, we are having equality here also, closed interval. I hope you remember the intervals here which you studied in first year PUC, that is the subsets are expressed in the form of intervals. Closed interval means both the end points would be included. So starting with 0 up to 10 we are considering here. So the function is defined in the closed interval 0, 10. That is the first thing. Now first let us see the values of the function at particular. Take the first case. Forget about the equality here. Now first thing I am writing, f of x is equal to 3. Under what condition? When 0 less than x less than 1. I will come to the equality part afterwards. When x takes the value strictly between 0 and 1, it is not equal to 0, not equal to 1. It takes a value strictly more than 0 and less than 1, between 0 and 1. Then the value of the function is given to be 3. Next, f of x is equal to 4. Come to the second part here. When does it happen? When 1 less than x less than 3. That is, when x takes the value strictly between 1 and 3, not equal to 1, not equal to 3, the value of the function is given to be 4. Lastly, f of x is equal to 5. Under what condition? When 3 less than x less than 10. In all the cases you observe that I am not taking the equality sign, I am taking purely an inequality, that is x is strictly lying between 0 and 1, between 1 and 3, between 3 and 10. Now what are the values of the function here? So when x takes a value, it may be say half, 1 by 3, 2 by 1 by 3, 2 by 3, any value that would be always equal to 3. That means it is nothing but a constant function. A constant function means it would be a straight line parallel to the x-axis. Automatically it becomes a continuous thing. Then between 1 and 3, again it is a constant, so it would be continuous. Between 3 and 10, again a constant, and it is continuous. Suppose we had 3x, 4x, 5x, we should have given a particular value, left hand limit, right hand limit, all those things we should have calculated. Because when you take the strict inequality, the values are exactly equal to 3, 4 and 5 respectively. Therefore, being a constant, it will be continuous in all these open intervals. So, next, in between points we are considering here. what are the in between points here? 0 to 10 the function is defined. So, what I do is I take the point x equal to 1, then I take the point x is equal to 3. Okay, because if I take 0 and all, no, I cannot calculate the left hand limit or right hand limit because it is not defined there at all. Here also it is not defined. Therefore, I can take the points 1 and 3. So, between 0, 1, 1 and 3, 3 and 10, we get the constant function which is continuous. So, continuity is calculated there. If it is continuous, we come to the conclusion. Only at that point x equal to 1, exact value x is equal to 3, we have to find out whether it is continuous or not. Now, at x is equal to 1, that is the first case. Now, at x is equal to 1, exact 1 I am taking. Here, how is the function defined? It is f of x is equal to 3 means f of 1 would be equal to 3. That is the value of the function, f of 1 is equal to 3. Look here, this number 1 can be approached through the values less than 1 and through the values greater than 1. That means for the left hand limit it would be equal to 3. Again, because of the absence of the variable x here, we need not calculate the limit here, which will directly we will be getting. So, left hand limit as that is limit of fx as x tends to 1 minus, that is this one, the value is directly given to be equal to 3. So, the value of the function is 3. The left hand limit, of course, you have to write limit of 3 as x tends to 1 means it would be equal to 3. Since it is a constant, directly you can write. Now, let me calculate the right hand limit also. It is limit of fx as x tends to 1 plus, that means through the values more than 1. What is the value? It is given to be 4. No question of calculations because the ready values are available. So, the left hand limit is, the value is 3. So, when you get the left hand limit, that is also since being 3, we cannot say anything about that one, whether it is continuous or discontinuous. So, we have to get the right hand limit. When the right hand limit is 4, the left hand limit is 3. What do you mean by that one? The two limits are not equal to each other. LHL is not equal to RHL. That is, when the limits are not equal to each other, the limit does not exist at all. So, when the limit does not exist, the function automatically becomes discontinuous or not continuous at x is equal to 1. So, here between 0 and 1, 1 and 3, 3 and 10, the function was continuous. Now, we are calculating or we are discussing about the continuity at a particular point, that is at x is equal to 3. X is equal to 1, we saw that the left hand limit and right hand limits were not equal to each other. Automatically it was discontinuous. Now, take the point x is equal to 3. 3 means here we are having the equality sign is here, that is f of x is equal to 5. In other words, f of 3 is equal to 5. Wherever equality is there, that becomes the value. So, f of 3, the value of the function is 5. Now, let me calculate the left hand limit. Look here, this number 3 can be approached in two ways, through the values less than 3, through the values greater than 3. So, for the left hand limit, this should be taken into consideration, that is limit of fx as x tends to 3 minus, you can see that that is equal to 4. See, in this case, no, we need not calculate the right hand limit at all, isn't it? Because the value is 5, the right hand, left hand limit itself is 4. When they themselves are not, these two are not equal to each other, there is no need to proceed further. Or if you want, you can calculate the right hand limit. Right hand limit means, again, we are considering this one. So, the right hand limit becomes 5. Anyway, these two are not equal to each other. The left hand limit is not equal to right hand limit. See, if these were to be equal, we should have calculated, we should have gone further. Now, since they themselves are not equal to each other, when the left hand limit is not equal to the value of the function, there itself we can come to the conclusion the function is discontinuous. So, the way the function is defined in this particular problem, when you take the inequality, that is in between 1 and 3, 3 and 0 and 1, 1 and 3 and 3 and 10, the function would be continuous because we are having a constant. Now, when you take two particular points at x is equal to 1 and x is equal to 3, we see that both the places the function is discontinuous, or we can say the function is not continuous. So, always when a problem on continuity is given, look at the definition. How it is, sometimes equal, unequal would be given. In that case the value would be given and you have to calculate the limit here. When less than, greater than given, always there will be 3 cases. When one point is involved in the domain, when 2 points are involved, there will be automatically 4 cases. So, for each problem all the problems will not be same. So, there will be slight difference. So, looking at the function, the way the function is defined, you have to decide how we have to discuss the continuity of the particular function. Now, in the coming sessions also, I will be working out some problems. In the next session, I will be considering some trigonometric function and want to discuss about the continuity of that one. Then there is one more type of problem where assuming the function to be continuous, there would be an unknown quantity which we are going to calculate, and finally there will be some book works which have to be learnt, that is we will be knowing, we will be discussing about the continuity of some standard function like a polynomial function, rational function, all those things now we will be considering in the coming sessions. Thank you.